Hi everyone and welcome back to NTE. Today's video is basically a follow-up video to the fertilizer industry video that I posted a few days ago, right? So in that specific video, I got a little bit into my feelings, right, in terms of the NPK ratio, right? Yeah, just listen to this. Now, I was doing a little bit of research and I realized that there is some sort of a lie that I've heard my teachers say previously. Okay, so normally you will read in your textbook or you will hear your teacher say that after this NPK ratio, right, you should have something in brackets, right, some number in brackets, okay, and that number must represent or represents the percentage fertilizer in the bag, okay. So in this bag, we've got a mixture of things, right? Some of it is actual fertilizer and some of it is just something we call fillers, okay? So soil and sand and limestone, okay? Right, so the textbooks will say that what is inside this bracket, okay, is actually shown on the packaging, okay? So I was looking for a lot of packaging for fertilizers and I realized that they don't actually put any number in brackets on the actual packaging of fertilizer. Okay, yeah, I know, right? Got a little bit sensitive there. I really did feel, bad because I felt like my teachers actually did lie to me, right? But I carried on doing some shopping, specifically online shopping, right? And I did find eventually, right, which was kind of bold of me to kind of get angry about the fact that I couldn't find a fertilizer packaging that had brackets on the actual packaging. I don't know. I feel silly now, but then, okay. Anyway, I carried on with my online shopping, right? And I did actually end up finding a fertilizer packaging, right, that actually has those brackets on the actual packaging, right? So that was very nice to see, and it it calmed down my anxiety in a way because yeah, I was starting to feel very anxious and very angry. I don't know why. Okay, so basically what I'm going to do is we are going to then practice calculating the whole masses and percentages again, right, using this specific fertilizer that I found, right? This one, I actually found it at Game, right? I actually found it at Game, and I'm realizing now that I did not check what the mass of this bag is. So let me just go back and check. All right, I found it. Okay, so this is a 5 kilogram bag, right? It should be written somewhere on this packaging, right? Obviously this is just a picture of it, so we can't move it around and actually find where that mass is, but that's a 5 kilogram bag of fertilizer, right? The specific one is for vegetables, flowers and shrubs, right? And it's a granular fertilizer, which means that if you actually take it out of the packaging, you are going to get granules, right? Makes sense because it is nitrogen containing. Okay. Also, a very nice thing about this, right, is that they note that this specific fertilizer is a slow release fertilizer, right? So they now actually make those type of fertilizers, right? There's fast release and there's slow release fertilizers, and this is all in response to the whole problem of over fertilization, right, that ends up causing things like eutrophication, right? So with your slow release fertilizers, the nutrients that the plants need, right, get released into water at a very slow pace, right? So to give the plants enough time to actually absorb them, right? So we are actually now making sure that the nutrients that we are adding into the soil are actually absorbed by the plants and don't go into our lakes and rivers and seas and things like that and cause problems over there, right? So this is one of the ways that they've now tried to compensate for the use of fertilizers in terms of trying to alleviate the problem of over fertilization. Okay, all right. Okay, so before we actually do what I wanted to do with this specific problem, I just want to have a little bit of a recap of what we spoke about in the previous video. Right? So basically the whole video, it just went through all the concepts that you had to know for the fertilizer industry for your exams, right? But really the takeaway from that was to know that there are different processes that we use, right, to make artificial fertilizers, and we end up with 3 categories of artificial fertilizers, right? So we have our nitrogen containing fertilizers, right? And these will always be in granular form, okay? And then basically your nitrogen containing fertilizers, okay, are then going to be containing substances such as your ammonium nitrate and your ammonium sulfate, right? And they can also contain urea, right? Okay, and then the second category that we ended up with was your phosphate containing fertilizers. And basically these fertilizers are the ones that then contain what we talked about, the superphosphates, right? So the compound superphosphates, right? And remember that had that scary looking formula, right? Usually this has water of crystallization, right? So when they form these superphosphates, right? So when they form this compound over here, right? It also forms something called gypsum, right? And gypsum is basically calcium sulfate, right? And then this substance then just forms part of the filler portion of your fertilizer, okay? And then lastly, we end up with your potassium, right, containing fertilizers, right? And those are going to contain substances like your potassium sulfate, potassium chloride, and potassium nitrate. Okay, so collectively these substances are just called potash. Okay, so collectively known as potash. All right, and then we basically just summarized and said that in conclusion we then get your NPK fertilizers, right, which are a mixture of ammonium sulfate, right, and then you also have ammonium phosphate, okay, and potassium chloride, right, in different ratios. Okay, so what are we saying, right? We're saying that these compounds, right, so ammonium nitrate, ammonium sulfate, and urea, right, those 3, okay, individually, those are fertilizers, right? But specifically, we say that they are nitrogen containing fertilizers, right? And then we're saying that your superphosphate, right, that is a fertilizer. This compound over here, that's a fertilizer, and specifically it is a phosphate containing fertilizer. Okay, and then compounds like potassium sulfate, potassium chloride, and potassium nitrate, all of those, right, are also individually fertilizers, right, and then specifically we call them your potassium containing fertilizers, right. And then we just summarize by saying that the most useful fertilizer, or the most commonly used fertilizer, is not just this substance, right, a nitrogen containing fertilizer or a phosphate containing fertilizer by itself, right, but it's rather something called a NPK fertilizer, right, where you have a mixture, right, of specifically the substances ammonium sulfate, ammonium phosphate, and potassium chloride in different ratios. Okay. Alright, so then with that said, okay, we can now then just go into this problem, okay, and actually start practicing yet again. How do you then calculate what is the mass of each of the substances, okay, so nitrogen, phosphorus, and potassium in a fertilizer bag, okay, and I'm just going to show you one method, right? You can use any other method that you want to, okay. We basically then said that the first thing that we do is that we would actually look at our NPK ratio, right, to determine the total parts, right, that ratio is made up, okay. So we would say, okay, 3 plus 1 plus 5, okay, that is 6 and 9, right, so this is 9 parts, okay. Right, so then from there we are then able to say that therefore, okay, this fertilizer, a mixture, consists of 3 out of 9 parts nitrogen, okay, 1 out of 9 parts phosphorus, right, and 5 out of 9 parts potassium. Okay, all right. So these nutrients, right, nitrogen, phosphorus, and potassium make up a total percentage of 26%, right? So this is the percentage fertilizer. Right. So then once we know that, we can then basically say that the other percentage, right, so the remaining percentage over here, okay, which is then going to be your 74%, okay, that is your filler, okay, so 74% is filler material. Okay, so from there we can also, from this NPK ratio, right, once we know the respective parts, right, of our primary nutrients, right, we can then calculate what is the percentage of each nutrient, right. So what's the percentage of nitrogen in this bag, what's the percentage of phosphorus, and what's the percentage, sorry, of potassium. Right, so when you calculate these percentages, right, you find that this specific fertilizer mixture, right, is predominantly very high, right, in nitrogen and in potassium, right, more so for potassium compared to nitrogen, right. So let's think about it a little bit, right. Why is it the case that this specific fertilizer contains a lot of nitrogen containing compounds and potassium containing compounds? Well, it all then just boils down to the function of these nutrients, right? So like they said in the beginning, right, like I pointed out in the beginning, this specific fertilizer is said to be more appropriate, right, for vegetable gardening and also for growing flowers, right? So your potassium, right, remember that the function of your potassium in your plants, right, is to improve your fruit and your flower quality, right? And they also actually note on the packaging over here that this fertilizer is going to help with the abundance of colorful flowers, right? And also with luscious, juicy fruit, okay? And then what is the function of nitrogen, right? The function of nitrogen, we said that is basically its main function is for leaf growth, right? So if you had to use this fertilizer for your vegetable garden, right, you wouldn't use it, right, to plant something like a potato, right, because a potato grows underneath the ground, so it's basically a root. You would rather use this fertilizer to plant things like cabbage and spinach and lettuce, right? Okay. All right, so moving on from there, right, one last calculation that we can do is then to calculate specifically what is the mass of each of these nutrients, right? So the mass of nitrogen, the mass of phosphorus, and the mass of potassium. Okay, right. And this now just makes common sense, right? The mass of each of these nutrients is just going to be their respective percentage, right, of the total mass of the bag, right? There it is, 5 kilograms, right? So times 5 kilograms. And then we also noted that when you actually add up all of these masses, right, then you are going to get the total mass of actual fertilizer in the bag, right, which in this case works out to be 1.26 kilograms, right, of actual fertilizer. Okay, and this mass over here is basically the 26% of this total mass, 5 kilograms. Right. All right, and then just to touch on the alternative sources of fertilizers, right? If we don't want to use the inorganic or the artificial fertilizers, right, then we need to speak about the use of organic fertilizers, right? And this is basically what was used before we actually started with this whole thing of artificial fertilizers. Okay, right, so I'm not sure what is the likelihood of being tested on this, right? But if ever it shows up, at least now you know. Okay. All right. So the alternatives that we have to inorganic fertilizers, right, are things such as bone meal, right? That is just crushed up bones, right? So you take bones and you crush them up into a powder form, right? And you use that as fertilizer. That is basically, we noted that is our source, right? Our natural source of nitrogen. Okay. You can also use animal manure, right? Or you can use compost, right? Now the difference between manure and compost is that manure is just the normal animal waste, right? So like cow dung, right? Now the problem with that is that you have very little control of what nutrients are actually in there. Actually, in fact, most of the time, as a farmer, you don't actually know what is in there, right? You just know that it's good, right, and it will help to grow your plants if you need it. Okay. Compost, on the other hand, is more controlled, right? So you can control exactly what type of nutrients do you want, right? So you can create a nice environment where you can actually decompose organic matter, right? So things like your vegetable peelings, right, and eggshells and things like that, right? So you can put all of that in like a garbage can, right, and that is like a controlled environment, right? And you can then have more of a control of what type of nutrients are actually are in that fertilizer, okay? And then you also can use bat or bird feces, right, or what they call guano, right? Fish emulsions, right, is also the same thing. It's just fish feces, right? You can also use dry seaweed, okay? Right, so that is basically your organic fertilizers, right? If you are the type of person who is very environment conscious, right, and you don't want to use these artificial fertilizers, right, you can still use the organic sources of fertilizers, okay? But then obviously organic fertilizers do come with their own advantages and disadvantages, okay? Right, so the first advantage, which is the most obvious, is the fact that these organic fertilizers are freely available in nature, right? So that means that they cost less than inorganic fertilizers, right? Because inorganic fertilizers basically have to be produced industrially, right? They then have a factor of cost, right? Right, and then another advantage of organic fertilizers is that because these fertilizers have basically a very high percentage of carbon bonds in them, right? They are organic after all, right? These break down and release these nutrients that the plants need, right, at a much slower rate than your inorganic fertilizers, right? So then this then helps us to prevent nutrients, right, leaching into the soil and then contaminating our groundwater and eventually leading to things like eutrophication, right, which we looked at previously, right? So with organic fertilizers, right, there's a less chance, right, of environmental issues like eutrophication developing. Okay. Right, but then in the same breath, right, we also then need to look at what are the disadvantages of organic fertilizers, right? The first one that becomes very evident or obvious is the fact that you need large amounts, right, of these organic fertilizers in order for you to actually have profitable commercial farming, right, which is ultimately the goal of any nation, right? When we want to farm, we don't want to farm for our own families like previously. We want to farm for the entire population, okay? So with your organic fertilizers, that then becomes a very big limitation, right? And yeah, that's usually the reason why we don't use organic or that was actually one of the reasons that drove, right, the development of inorganic fertilizers, okay? Just to add on over here, sorry for jumping around, right? Another advantage of organic fertilizers is, right, is that it improves, right, or they improve soil quality, right? So that's one of the reasons why you would actually opt for organic fertilizers, right? So if your soil quality has decreased, then you would like give the soil a little bit of a break and add some organic fertilizers into it just to help it improve the soil quality, okay? Right, and then going back to the disadvantages of organic fertilizers, funny enough, right, organic fertilizers actually contain small quantities of the necessary plant nutrients, right? So the nutrients that we're talking about, right, your nitrogen, phosphorus, and potassium, right, so those primary nutrients, right, organic fertilizers actually contain those nutrients in very small amounts, right, which feeds back to the first disadvantage, meaning that you need very large amounts of organic fertilizers in order to do any significant, right, large scale farming, okay? And then lastly, right, we can also note that one of the disadvantages of organic fertilizers is that due to the fact that organic fertilizers have such a slow release of nutrients, right, so actually much slower than your inorganic fertilizers, right? And this is basically because of the fact that your organic fertilizers, right, first have to break down, right? They first have to break down and decompose first, right, before these primary nutrients are actually available, right, to be then dissolved into the water, right, and then be absorbed by the plant. Okay, so it's a very long process. Okay, so due to the fact that your organic fertilizers have such a slow release of these primary nutrients, right, those nutrients may actually be available for the plant, right, too late. Okay, so then it actually defeats the whole purpose of farming, because what is the point of actually using organic fertilizers if you're not sure if your plants that you're trying to grow are actually going to have the necessary nutrients for them to grow, right? What if you do that and then it ends up having a poor batch of crops, right? Your crops are not healthy, right? Because they are deficient in nitrogen, or they're deficient in phosphorus, or in potassium, or whatever, right, that the plant actually needed, because those nutrients were not actually available for the plant when the plant was actually going through its growth cycle, right? So they end up for causing more harm, right, than good, right, which then costs the farmers even more, because now you wasted time, right, you wasted energy, you still need to pay your workers, because yeah, it's just a very long cycle of things, right? But just note that I'm not trying to promote inorganic fertilizers, guys. I'm not, okay? It's up to you, right? It's a personal choice. And rather than saying it's a personal choice, right, we should rather say that if you want to be a farmer, you should make more of an educated choice of what you want to use as your fertilizer, your choice of fertilizer, okay? Are you going to be using inorganic fertilizers, right, even though they are quite expensive, or are you going to be using organic fertilizers, right? So with that said, matriculants, let me stop talking. I will see you guys next time.